adding or subtracting over and over again. What word do we see in linear? Line. So what does the graph look like? A straight line. So we know if we have a straight line, that it's linear. What do you look? I don't have one right now. See if somebody else. So linear means line. So we know if it's a straight line, we know it's linear. And we know that we're first looking at slope. And what letter is slope in y equals mx plus b? M. They tell you that right here, right? So this m, they're telling you, is this m. They're telling you that m is slope. So in case you forget for some reason, m is slope. So make sure, Armani, you put that computer away and write this down. What words do I see when I'm reading a word problem that tell me something's a slope? Per. What else? Each. Every. So if I see like $10 per day, you're adding $10 each day for every. Things like that. When I'm reading a word problem, I know those words usually refer to my slope. Then here's my slope formula. But the most important thing is that people forget how to label. How do I label my points?
Label.
X1, Y1,
X2, Y2.
and then we plug it in. So a lot of people put X1, X2, Y1, Y2. Remember, it's X1, Y1, X2, Y2. And then we plug it in. And that is your slope in here. So we usually use this if we're given 2 points and told it's linear, or also if we're given a table. So if we're given points or a table, and we have those points, that's when we use the slope formula. Then we have slope-intercept form. So we know n is slope. What is b? B is your y-intercept. What words mean y-intercept? Starting, initial. What's your x-coordinate for your y-intercept?
0.
0. So if like you're looking at a table and you see x is 0, you know that's your y-intercept. Starting. So starting.
We can't see through you.
All right. So all these mean the same thing. If they're looking at y-intercept starting initial, we know it's your slope. See point slope form?
Oh.
This. Did we go over that at all this year?
No.
Cross it out.
See, I want to. We didn't go.
No, that's what I thought. Point slope form is 0. Standard form is ax plus by equals c. That's when x and y are on the same side. When both are in standard form and we're doing system of equations, what do you use? Substitution, elimination, elimination.
Is that like when we do cos?
Yeah. Okay. What does arithmetic mean? Adding or subtracting. Because A stands for at, right? So it's adding or subtracting. See that slope formula and arithmetic are right by each other? See how they're right one after the other? That's basically telling you slope and arithmetic are basically the same thing. And if you don't remember this, we went over this in 2A when we went over those quizzes. If you were here, I record every session. So if you want to go on and watch that 2A and go over these things right here, you're feel free to. So arithmetic means adding and subtracting over and over again. So recursive. What word does recursive sound like? Re-something. Repeating or reoccurring, right? So this is basically telling me like what's happening over and over again. So recursive is just like what's happening over and over again. Yeah. Yeah. So what does a to the n minus 1 means? It means take the term before. So it's telling me a pattern. So the recursive is telling you a pattern. So a to the n minus 1 means take the term before, does D mean? Difference. Difference is the same thing as which thing here?
What?
Y equals mx plus b. Which one stands for your difference? M or D?
B.
Your slope. D is your slope. Or what's being added? This one? Take term before. Yeah. Take term before. Guys, please make sure we're not talking. So D in both these means difference. It's just another word for slope. So if you see D or anything like that, it's difference, and it's just another word for slope. So notice that I put N, I put the slope formula, and I put D all in the same color because they're all the same thing. What does A1 mean? First term. So this is telling me first term. Or when x equals what?
0. 1.
What does N mean? What?
Oh. Wait, you have N as a term number?
N is term number. So N is term number. So explicit is like a rule. So recursive is just telling you. Recursive is telling you the pattern. So take the term before and do whatever to it.
Wait, up.
So recursive, guys, please focus. Recursive is a pattern. So what's happening over and over again? So when they're asking for recursive formula, you know the only thing that you need to plug in is what letter?
1, D.
D, right? This stays. Just take the term before and do something with it. Explicit is a rule. So like if I'm trying to get the millionth term, or sorry, 100th term, if my difference is 2, right? If my slope is 2, what am I doing over and over again? If it's still adding, even though it says difference, in this case, it just means your slope. So if my difference was 2, you'd be adding 2 over and over again. If I want to find my 100th term, how many times would I have to add 2 over and over again? 100 times. This is so I don't have to do this. This is to make the little formula. So to get the 100th term, I would set up the equation like this. I would take the first term, whatever the first term was, and then N is the term number. So if I'm looking for the 100th term, what would I plug in for N? 100. And what would your D stand for?
Slope.
Your slope, whatever's being added. And then you would find your answer. So this gives you more of an answer. It's a rule, and it gives you an answer in return, like a term number. Recursive is just like a theme, what's going on over and over again.
So it doesn't give you an answer.
Yeah.
It's an equation.
Mm-hmm. So recursive, like if I wanted to find the 100th term, all it's telling me, guys, all it's telling me is take the term before and do something over and over and over. So if I wanted to find the 100th term, I would need to take the 99th term and add whatever 2 to it.
What might the question be with recursive on the?
They would give you an equation usually, and I did it during Unit 2A quizzes. There's a bunch of questions. So I would look over that to see the type of questions they would ask. Okay, exponential. What does exponential mean?
Multiply.
And I like that you said exponent. What is in the exponent? X, right? X in the exponent, and you know it's multiplying over and over again. What words would signify, or signs would signify that something is exponential?
Double.
Double, triple, something like that. Does that mean multiple? And percentages. So like if something's increasing by 20%, you know you're using exponential. So either like double, triple, it will say multiplying, or you can see it on the table. Or you know if they're saying like something increases or decreases by 1%, you know you're going to be using exponential.
So
Yeah.
division would just be
Division is technically multiplying by 2. So like if you were going dividing by 2, it's the same thing. It's the same thing as multiplying by 1/2. So rare, where? Double, or like if there's a percent sign. So if something says double, triple, or if there's a percent sign, or it says, you can notice the theme is multiplying, you know we're using exponential. So make sure you're writing this down. I would write it right on here. So y equals a beats the x. What does b refer, or what does a refer to? Initial, starting, and if there's nothing after it, it's usually your y-intercept when x equals 0.
So that is not your y.
It is, and remember we went over, if you were in the session yesterday, remember we went over end behavior and transformations. That's the only time that if there's something after it, that's the y-intercept when x equals 0 is your a. B is what?
Slow.
Not slow. Not slow. There is no slope in exponential. Guys, can we please be quiet while I'm going over this? What is B? Oh, that's your growth. Growth or what?
Okay.
Perfect. Growth or decay factor. So if they ask for the factor, you know you're writing that whole number in. So if you were here on Saturday, you knew that when we talked about factor, they're asking for the whole B. What was inside that parentheses?
So like, would it be 1 minus, or you would do like?
Whatever's it. If it asks for the factor, it's whatever is in the parentheses. You wouldn't do 1 minus. If it asks for the rate, then you would do it.
So like the answer from 1 minus would be the factor.
We have somebody at the door.
So what's growth mean? Cool. So when it's growth, we know the growth factor is what? What do we know about that number?
If it's less than 1, it's growing. If it's more than, I mean, if it, yeah,
It's more than
if
one.
it's more than 1, it's growing. If it's less than 1,
Good job.
So decay is it's a number smaller than 1. And we went over this on the quizzes yesterday. So if you need to watch that quizzes, that's on my Google Classroom. But if the number's bigger than 1, we know it's growing. If the number's smaller than 1, we know it's decaying. So if they're asking for the rate, I would need to figure out what percentage is it increasing by or decreasing by. If it's asking for the factor, I would need the whole thing inside of here. And so if you need more information on that, make sure you watch that quizzes, and if you have questions, you can ask me after school today. All right, next one. What is geometric mean? Multiply. So it's the same thing with arithmetic. Notice that exponential and geometric are right by each other. And that R is the same thing right here. R is your growth decay factor. So right here. Or what is it growing or decaying by? So it will be like something like multiplying by whatever number. So R is your same thing, is your growth or decay factor. Is R. N is the same thing right here. N is still your term number. So that N is still the same. And A1 is still your first term. So the only difference is that this recursive is giving me a rule. So if something's multiplying over and over again by 3, what would your R be? 3, right? If something's multiplying by 3 over and over again, I know my R would be 3. So it says take the term before. If I want to find the 5th term, it means take the term before and multiply by 3 to keep. So that's the same thing as recursive reoccurring up there. Explicit is like if I wanted to find the 20th term, I would plug in 20 for N and fill in these two things. So A1 is still your first term, and R is still your growth or decay factor. So it's the same thing as the arithmetic. We're just now using R, and it looks a little bit different, but you're given these equations. So if you see anything saying like sequence or like anything A to the N, any of that sort of stuff, get that reference sheet out and make sure that you're using it to answer those questions. I'm going to go on them. Okay. All right, compound interest, don't worry about for right now, but what compound interest was? There may be one question on it. Compound interest, remember we did the car payments?
No.
The activity with we looked up our car, we found that the more months we paid, we're actually paying more money. And so I'll explain that last time. Yeah.
That's what it says?
At the end, it's like your end term. There may be one question. But but I'd rather you know everything else first, and I'll do that last. I'll do that last. Quadratic. How do I know if something is quadratic?
It has to square.
I know if the highest exponent, I'll wait. I'm trying to help you guys out. So if you're not going to take this seriously, you're not going to go over this with me, you can just go out there and watch the video and do what you need to do. But I'm trying to help everyone who wants to help. So we know the highest degree, remember degree means exponent. If the highest exponent is 2, or there's something with the x squared, or any letter squared, we know they're talking about quadratic. So we know if we see an x squared, we are going to that part of the formula sheet. So like things like this, like you have those sticky note things. So when you get to the reference sheet, I don't know if you can do it on there, but when you see that x squared, you can put a sticky note and say like quadratic. Like I would even go through your test first, even looking at the questions, and figure out like when do I use each thing.
Oh, we don't compound or quadratic?
Nah, I'm skipping compounds. I'm not worried about that. All right, standard form is when all 3 things are on one side, right? So first you need to make sure everything is on one side. If quadratic something that you struggle with, then that's something you should come during class today. We're going over quadratic. So remember, A is the one with x squared, B is the coefficient of x, and C is the constant, or the number by itself. Out of those, which one is your y-intercept? C. C is your y-intercept. Your starting, initial. So when everything's on one side, it's in standard form. C is your starting, your initial, when x equals 0. Cool. Vertex form is we can either find the vertex, right, or transformations. Remember, minus h to the right.
Oh.
Remember all that? That equation's given to you right here. They even say minus h. So they're telling you to switch it. So I'm going to put transformations right here. So minus h is which direction?
To the left, right.
Right. Plus h.
To the left.
And they're talking about this h right here. What about plus k?
To the up.
Plus k, moving up, minus k,
Down.
moving down. So, and then when we look at A, right, the A right here, both of these A's, when we have a positive, what does she look like? She's smiling or frowning? Smiling. So if A is positive, we know it's going to be smiling. If A is negative Nancy, we know she's going to be frowning.
So she's not.
If A is a positive number or there is no number, we know it's going to look like we're going up.
Hold on. What's the, okay, the little, positive intersection?
So these A's, the leading coefficient, that's in both vertex form, both of these A's, if that number is positive, we know it looks like a regular parabola, smiley. We know if that number is negative, it looks like a negative Nancy, and if you need help with that, we are going over that today more in depth. But I want to get through this first. Yes?
Isn't there another thing that has to do with transitions that has to do with the exponent or something?
So transformations, when it is in the exponent, that's transformation of exponential. That's what we went over yesterday. And so minus h is actually in the it's in the exponent. But it's still the same thing. So it could look like this in here, but exponential, it will look like this. If it's x minus h, and then plus k. So that's transformations of exponential.
It's still up.
Yeah. So, when we're going, and so please make sure you're making note of this, and I'm not going to go too in depth because if you do need help, I have that session today. So if you're going from standard to vertex form, what do we need to do?
You need to subtract the
Constant. What's that called? Completing something. Completing the square. So to go from standard to vertex, we use completing the square. And that's the one where I say the blank really weirdly. I still hear talking.
Me too.
Again, if you do not want to listen to me, then you can go out there and watch the test one on your computer. So that the blank thing, when going from standard to vertex form, that's how you do it. And so if you need help and you kind of forget that, make sure you come today during flex. And don't go to advisory, just come right here. Make sure you sign up though, because I let all your advisors know already. Quadratic formula. Do you guys see how quadratic formula is already given to you? So first you need to make sure it's in standard form where everything's on one side. Now the whole quadratic equation, what answer, when I get the answers, what does it give you?
It intercepts.
See, that's x right there. X intercepts. Solutions. Roots. Zeros. So if you see a question where it's quadratic and any time they're asking for zeros, x-intercept, solutions, roots, you know you can use a quadratic formula and get your answer. So if you forget how to factor, if you forget how to complete the square, if you forget how to use your calculator and look at the graph, you can always use this. And it's telling you to find your x-intercepts. And this is always given to you, no matter if it's calculator or not. Yeah. Zeros. Now, there's two things that I define from this. The first one is negative b over 2a. Right? What does negative b over 2a give me? Axis of symmetry. The other one's discriminant. Axis of symmetry, which is your x coordinate of your vertex. How would you get your y coordinate of your vertex?
Plug it in.
Plug it back into the original equation. So negative b over 2a gives you your axis of symmetry. And then, as Ebony already said, b squared minus 4ac gives you your what? Discriminant. Remember, that discriminates how many solutions.
So like, if it's two infinitely maybe.
So, I'm going to go over that. So, if it's positive, if you get b squared minus 4ac, you plug it in, and you get any positive number, no matter what it is, how many solutions is there? Two solutions. If you do it and it's negative, how many solutions is there? Zero or none. That's why it's rounding. Yeah.
Wait.
Right here. Plug it in. If b squared minus 4ac equals 0, how many solutions? One. Because remember, if the square root is 0, it's just 0.
Wait, so BT minus 4AC finds how many?
How many solutions? So if they're asking for how many solutions or the discriminant, that means you're using that formula. If they're asking what are the actual x-intercepts or solutions, you use the whole thing. Like if you plugged in A for A, B for B, and C for C, and your answer ended up being 0. If you're confused about like content or what I'm writing, right here. So b squared minus 4ac, when I plug that in, so say like A was 5, B was 6, C was like looking at this right here, and I plug it in and I get a positive answer. I know I have two solutions. I know I'm going to have two x-intercepts. If you get a negative answer, what does it say in your calculator? Error. 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 It is an error when you type in how many solutions are there. None. And if you plug it in and you get straight up 0, like you plugged all these numbers in for B, A, and C, plug it in, you got 0, it's one solution. Remember, you can always type it into y equals. After this, we're doing calculator cheat sheet. So, this is your reference sheet. Yeah. All right. This is the last couple things. What does rate of change mean? Slope. So even if it's quadratic or exponential, and they mention rate of change, what are you finding? Slope. And it even tells you what to do. The change in y divided by the change in x. So they can say, like, find the average rate of change for when x is 3 and when x is 5. And you would have to find the slope of those 2 points. All right. I'm almost done. What does mean mean?
The average of data.
So if they use the word average, you know they're talking about mean. See how there's an x with a line over it?
Yeah.
That's how it looks in your calculator. If you see an X with a line over it, that means the mean. And we went over that, we're gonna go over that in calculator cheat sheets. But an interquartile range, remember on QR, Q3 minus Q1. We'll be going over that too. What does a quartile mean? How much percent of your data?
25%.
Good. So each quartile is 25% of your data. Each quartile is 25% of your data. Last one's mean absolute deviation. So we went over this, but it basically tells you take the sum, and we're going to be going over this again on Thursday during Flex, so if you don't remember it, we'll go over it. It's telling you take the sum. What does sum mean? Adding. So, and this thing right here means sum. Take the sum of the distances. What does distance mean I'm doing? Distance. It's telling you the definition of mean absolute deviation. Yeah, subtracting. What do these absolute values mean? Make the answer what? Make it positive. So we find the distance is how far away each data value is from the mean. So how far away is from the mean divided by the number of data values.
So that's
Are these gonna ask math because this?
Yeah. So if you don't get that, what should we do? Come Thursday session. Okay. So